Two components of saponification includes a fat and alkaline substance are required to produce soap at home. Since this process of saponification involves hydrolysis of lipids when they react with alkaline, which produces glycerol and fatty acid salts. Therefore, the three ester bonds in a triboglycerate must be broken via heat exposure under certain fundamental circumstances for sonification to occur. The bond breaking will result in the formation of alcohol and carboxylic acid. Finally, when a carboxylic acid depletes, the positively charged ion in salt solution are drawn to negatively charged, creating soap. Therefore, in this course of organic chemistry, the Saponification Lab and their reactants is a topic of discussion because the process of hydrolysis, which is known as saponification, has been understood for ages. Animal fat and lye were the traditional ingredients used to make soap, which was created by passing water through ash from wood. The goal of this lab is to use a sonification reactant to turn commercial oil into soap. So the compound that we're going to be using is found in the subtopic of inorganic chemistry, which is sodium hydroxide. So the imagery shown in the figure 1 in the lab report under methods 1 through 3 with discussion is extra equipment used during the first step, the preparation of the solution. Can be seen when sodium hydroxide was mixed into water. The lab measuring equipment was used to produce accurate measurements. The first step included a funnel and beaker, which was filled with water to stir the lye into an earthenware flask, and gradually it was poured into a beaker. Secondly, after combining all three oils into a 400 milliliter glass beaker, the step will include the boiling of liquids, using the process of heat transfer by pouring a pint of solution into a boiling flask. An apparatus will be used to heat the solution under a single burner camp stove for approximately a minute. During the process, the oil's temperature will be verified to be about 125 degrees. Heat and water and air in the process, which usually occurs at high temperature, will speed up the reactants. By then, once the reaction occurred, the stove was turned off and the lye would be left to cool down. So, the high lengthy carbon chains that make up soaps are carboxylic salts. Therefore, it's essential for manufacturing soap. If it's too low, become rigid. After a few minutes, the product in the round-bottom flask began to turn pale orange due to the flux. The substance changed to a bright brown after it began to boil. It finally changed to a light yellow after around 25 minutes. It was a first hazy combination before turning into a creamy, off-white solution when compared with the sodium chloride solution. It was divided into two levels. The white off-creamy material was at the top and the sodium chloride solution was at the bottom. The soap was formed into a solid that was white gray throughout the vacuum filtering process. Third, when the oils and lye combine, what was once a liquid is transformed into blocks of soap. When prepared correctly, the final product is not a combination of lye. During the experiment, the analysis of how soap is made through the hydrolysis of an alkaline was successful. During the process, it is understood how long chains of fatty acids and oils and fats are broken down to produce soap. In the second part of the experiment, it was discovered that commercial degreasers, such as orange, are better than soap as cleaning agents because of the process which the reaction occurs. So, anyways, I enjoyed this lab. Um, I enjoyed making soap, and thank you.